8.1, and we will select problem 11. And please be on standby for any other question. Okay, let's go to 11, part C. Okay, the final probability distribution, the random variable X is, okay, complete parts A through F. Wow, okay, good. This is a discrete probability of distribution. So I'm assuming you added up all these probabilities. So let me copy the table and P of X. And so this is 0, 1, 2, 3, and 4. And I got 0.378, 0.267, 128, 137, and 090. Okay. So now I see that you see me instead of what I wanted you to see. So where am I? Right here. And let me switch this. Okay. So we are given the discrete random variable. The discrete random variable can take these, just these 5 possibilities, answers, right? X could be 0 or 1 or 2 or 3 or 4. That's it. Every variable, every element of the or possibility of the random variable has a probability attached to it. So the probability for 0 is this, for X to be 1 is this, and so on and so forth. Now this will be a probability distribution only if the sum of all probabilities equals 1, and if all probabilities are between 0 and 1. I know that this is not what you're asking, but I'm reviewing this, so this is fine. So I'm adding them up: 0.378, 0.267, 0.128, 0.137, and 0.090. And I got exactly 1. Nothing below, nothing above. So I will say yes for part A. I checked. Now for part B. So because the sum of the probabilities is 1, and each probability is between 0 and 1. No.
Because it's between 0 and 1 inclusive.
Careful. Inclusive, yes. Between 0 and 1 inclusive. Be very careful with that. Thank you very much. Okay. Graph the discrete probability distribution and choose the correct graph below. Okay. So let's graph this first. In part B, I have here probability or percent. I have here the values of the random variable: 0, 1, 2, 3, and 4. So no probability, so the highest probability is 0.37, right? So 0.1, 0.2, 0.3, 0.4. So for 0, it will go to 0.378. I have to use a different color. So 0.378. So this is it. For 1, 0.267. 1, 2, 6, 7, something like this. 0.12. 0.137. And 0.09. So for 0, for 1, 0.26, for again for 2.
Looks like it's graph B.
Yes, I'm just checking, making sure that everything is a little bit higher and below. Yes. None of these make any sense. Good, very good, thank you. Compute and interpret the mean of the random variable. Perfect. So let me stop sharing. Maybe not. I don't want to stop sharing. I want to show you with the calculator here. Sorry for not having this ready. Perfect. So we go to edit, stat edit. Wake up, wake up. Thank you. So stat edit. And we're going to put in L1. I'm going to have to clear and enter and clear and enter. So in L1, I have the values of the random variables: 0, 1, 2, 3, and 4. And probabilities, 0.378. Then 0.267. Then 0.128. And two more, 0.137. And last one, 0.90. 0.90. Enter. And now we go to out of there, second and quit, and go back to stat. Stat. And we want to calculate one variable stats. Press enter. The list is L1, the frequency or the probability, same thing, L2. Okay? So now we're asked to find the mean. Here is the mean. Same notation that we had before. And you notice that there is no sample because all probabilities add up to 1. All frequencies add up to 1. So this is the standard deviation. So I will write for part C, and I'll stop sharing in a second. So I have mu is 1.294, and the standard deviation is 1.33325. And if they want me to find the variance, I'm just going to square 1.3325. So I'm going to stop sharing for a second. So you see what I wrote. So the mean is 1.294. The standard deviation is this, and the variance will be this number squared. And now I'm going to share again and go to the problem right here. Okay, compute interpret the mean. Okay, type an integer or a decimal. Do not round. Okay, so 1.294. 1.294.
We not find the mean to the stat con because when I do it, I use the stat con. I thought it's the same the way that we find the mean. So at the time, I put the number from stat con. It keep say it's error.
You have to get the same answer. It's absolutely mandatory to get the same answer. There is only one correct answer.
And that's why I'm not like why it's getting wrong.
So let's see. Where is my custom? It's not in edit.
Stat. Calculators.
Calculators, yep. Thank you.
Custom.
Custom, yes, thank you. Select the variable that is x, select the weights, which is p of x, and just compute. So here it is, 1.294 and 1.332532, exactly what we got.
I do the I put stat and then the below the custom calculator. I click the second one.
Okay, so that's fine. We all make mistakes. That's no problem. So do you know now? Do you understand now?
Okay, thank you.
That's it?
Yes.
Okay, should we look at the problem and continue it, or? So,
continue it since
yes, absolutely. I want to. Yes, makes sense. The observed value of an experiment will be less than the mean. As the number of experiments increases, the mean of the observations will approach the mean of the random variable. As the number of experiments decreases, no. The observed value of an experiment will be equal to the mean of the random variable in most experiments. No. As the number of experiments increases, the mean of the observations will approach the mean of the random variable. Compute a standard deviation. Okay, we already have it. Round to 1 decimal place, 1.3. What is the probability that a randomly selected student has a parent involved in 3 activities? 3 activities? This is the probability. What is the probability that the randomly selected student has a parent involved in 3 activities? So K, okay, so the number of activities, a parent, blah, blah, blah. So type an integer or decimal, do not round. So here's the probability for 3, 0.137. What is the probability that a randomly selected student has a parent involved in 3 or 4? 3 or 4 are mutually exclusive. I cannot have somebody who is involved in 3 and involved in 4 at the same time. That's why we are going to add the probabilities without subtracting their intersection. There is no intersection, right? So let me stop sharing for a second. If you remember, we talked about the non-mutually exclusive. So the probability of A plus the probability of B minus 1 time the probability of the intersection, but that's not the case here. This case is if a person or a parent is involved in 3 activities, cannot be at the same time involved in 4. So the probability of OR here is this plus this. Here the probability of OR is this plus this minus the intersection once. So this is our case. So we're adding these two. So I'm adding this plus this. Where am I? What am I doing here? Okay.
I have the answer.
Yes, I'm ready. Thank you for saving me.
0.227 is what I got.
227. I trust you. Excellent. Good. Do we understand this problem that we just finished?
Yes, thank you.
Thank you. Other questions for me here? I thought somebody else had questions, please. Maybe a different problem that you worked on or quiz or anything. Is there anything else we need to discuss before we look at 6.2?
I'm honestly good right now. I don't have any questions.
Okay. You can.
I do.
Yes, I'm ready. Please. Yes.
Question 17.
Still from 6.1?
Yep.
Okay, let's take a look. Awesome. I love it. If we don't have interaction and we don't talk about problems, then we learn much less. Okay. So again, we can go directly. So was part A?
It was part B.
Okay, but we have to, we can continue because I'm sure the numbers are different, right? So
Yeah.
calculators, and I have to calculate my numbers here. And custom, and select X, and then select the frequency or the probability and compute. Okay. So I'm going to copy. I got mu to be 4.9 and the standard deviation to be 1.9924859. Okay. So I'm going to stop. No, I don't want to stop sharing. I want to go here. So round to the nearest tenth as needed. So it will be 4.9. Use the probability distribution to find the variance. Okay. So we know how we found the variance, but I have to square it. Okay, so 1.9924859 squared. I got 3.97, round to the nearest tenth, so it will be 3.97, which means will be 4.0. Use the probability distribution to find the standard deviation of the probability distribution. What? We already have it. So round to the nearest tenth as needed. Again, it's 2.0. Use the probability distribution to find the expected value of the probability distribution. Excuse me? What are they talking
that
about?
question was a little funky when I was doing
Yeah,
it.
what are they?
4.9, I think.
Yeah, I mean, they're just testing us. Testing our understanding.